Hello everyone, I hope you are well, staying safe and healthy. I am Ehsan Ronagh and I have the duty to present this research on behalf of others. The title of our research is A New Paradigm in Generative Design, Linking Parametric Architecture and Music to Form Finding. The present study is aimed at presenting a new design and construction method as a generative design that can use two main characteristics of sound, namely frequency and intensity over time. The design also forms the numerical outputs of the music to deform the modular two-dimensional geometric patterns and transform them into three-dimensional parametric shells. So, the resulting research is fully applicable at the large scale such as urban landscape and small scale as interior design. As you know, numerous studies have been done on the relationship between architecture and music, including examining this relationship with the conceptual approach. Some common factors have been used in this area such as rhythm, harmony, color, symmetry, proportion, and etc. On the other hand, there are studies in this case based on form and sound physics, which are highly applied works. Some of the outputs from these studies were used as a basis for our research process. You can see a summary of these studies in this table. As you can see, the study for mathematical relationship between architecture and music has existed since the time of Greek and Plato up to now. For instance, you can see a project made by Zaha Hadid architects reinterprets sound waves, or Martin Wattenberg made the custom software that draws musical patterns in the form of translucent arcs. But there are two experiments in these studies that highly matter to us. One experiment is conducted by German physicist Ernst Chladni, vibrating the sand grains on the plate by violin bow, and the other is cymatic science, which is invented by Hans Jenny. Now, let me show you the theoretical framework of research that can be expressed based on such a structure. As you know, in algorithmic thinking, we have three sections: input, a rule or algorithm, output. In this process, we should consider music as an input. As you know, music is a kind of sound which is made by some characteristics, such as frequency, wavelengths, amplitude, and speed. So, we can get numerical outputs from these features by Firefly plugin in Grasshopper. In the next section, you can see we make a connection between mathematics and geometry by means of parametric architecture. You can see several algorithms that are defined to make a different type of two-dimensional modular platforms and then transform them into 3D forms based on music. And finally, we have some 3D parametric shell which can be fabricated by different ways. Now, let me go back to the algorithms which I mentioned that before. One of them is music spectrum curve line. By this one, we can calculate the average frequency spectrum of a music track during the time. In here, you can see two-dimensional modular patterns algorithms for making basic platforms. Now, for changing basic platforms in order to deformation them, we use three methods. The first one is pocket deformation and deformation by attractor point or attractor curve. The second one is Hankin's method, and the last one is Rosetta deformation. Finally, we script an algorithm for the deformation of those patterns in 3D shapes based on the attractor curve. This curve is music spectrum curve line which was pointed to before. And these are different types of prototypes that are made with different types of music by this approach. Finally, we implemented this project based on this study. In this project, a part of an Iranian music piece by Mohammadjavad, the top Persian traditional music singer, and Sohrab Purnazar as a composer, was used as the algorithm input, and its nonlinear medium frequency spectrum was obtained. Using the basic geometric algorithm and deformation methods described earlier, we created the initial pattern of Rosetta geometrics and Gerechini in a two-dimensional form, which is found in Iranian architecture. Then, based on the attractor curve algorithm, the effect of that nonlinear medium spectrum resulting from the music is applied to the designed two-dimensional patterns. So, the output was a parametric three-dimensional shell that was affected by a specific music piece. And finally, the whole process of this study can be illustrated in these figures in detail. You can see three levels of algorithmic thinking: input, rule, and output. Thank you for your attention.